With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
An aluminum rod having a length of 90 cm is clamped at its middle point and is set into longitudinal vibrations by stroking it with a rosined cloth. Assume that the rod vibrates in its fundamental mode of vibration. The density of aluminum is 2600 kg per meter cube and its Young's modulus is 7.8 into 10 to the power 10 Newton per meter square. Find A part, the speed of sound in aluminum, B part, the wavelength of sound wave produced in the rod, C part, the frequency of the sound produced, and D part, the wavelength of the sound produced in air. Take the speed of sound in air as 340 meter per second. So we are given the length of the rod, capital L, is equal to 90 centimeter, and we are given density of the rod, rho, is equal to 2600 kg per meter cube, and the Young's modulus of the rod is 7.8 into 10 to the power 10 Newton per meter square. In A part, we need to find the speed of sound in aluminum, and the speed of sound in solid, denoted as V, is given by under root of Young's modulus divided by the density. So Young's modulus is 7.8 into 10 to the power 10 divided by 2600 under root. Upon calculation, we get the speed of sound in aluminum nearly equal to 5480 meter per second. In the B part, we need to find the wavelength of sound waves produced in the rod. For this, we need to note that the rod is vibrating in its fundamental mode of vibration and it is clamped at its middle point. Since it is clamped at its middle point, there is antinode at middle point. And there are no other nodes or antinodes formed in the rod because it is vibrating with a fundamental mode of vibration. Therefore, the wavelength lambda is equal to 2L and L is equal to 90 centimeter. Therefore, the wavelength lambda is equal to 180 centimeter. This is the wavelength of sound produced in the rod. For the C part, we need to find the frequency of sound in the rod. So nu, the frequency, will be equal to speed of sound in the rod divided by the wavelength in the rod. The speed of sound is 5480 divided by lambda in meters, which will be equal to 1.8. So the frequency is equal to 3050 Hertz. This is the answer to C part. The frequency of sound passing through air will be equal to the frequency of sound passing through the aluminum rod. Therefore, nu will be equal to 3050 Hertz for the sound traveling through air. We are given the speed of sound V in air is equal to 340 meter per second, and we are told to find the wavelength of sound produced in air. Now wavelength lambda in air will be equal to speed of sound in air divided by the frequency. This implies lambda A is equal to 340 divided by 3050. This will be equal to 0.1115 meters, or we can write it as 11.15 centimeter. This is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.